Okay, in this video, I'm going to provide a brief demonstration of this online utility. Looks like it was created by Chris Preacher and his colleagues. Basically it involves, we're going to focus in on probing interaction effects in the context of HLM. So you can see on this page right here, they've actually got, they actually have several different utilities, some for multiple linear regression, some for HLM, and then latent curve analysis. And we're going to mainly focus in on the utilities related to HLM. And more specifically, I'm going to demonstrate this particular utility for a two-way interaction effect in the context of HLM. And more specifically, I'm going to model or demonstrate its use with when I'm probing a cross-level interaction effect. So, if you click on this page right here, what I want to do is just kind of briefly show you this before I get on with the demonstration. Basically, on this page right here, the authors discuss three different cases that you can use this their calculator or their utility for. Case one involves a circumstance where you have an interaction effect taking place within level one. So essentially you have two level one predictors that are interacting. Then case two involves an interaction effect taking place at level two. So your two level two predictors are interacting. And then case three reflects a cross-level interaction between a level one variable and a level two variable. So and this is going to be the case that we're going to demonstrate in this particular video. So for each of those cases, they created a separate calculator. Even though the form of the equations are the same and a lot of the same information is being fed in, they went ahead and did a nice job of just setting up three different calculators to kind of reduce the likelihood of you having problems when it comes to inputting your data. So what you'll do is you'll basically run your HLM analysis in whatever program you're using. I'm going to demonstrate it using SPSS, and then you're going to take information from that analysis and feed it into these boxes here, and then you can generate a plot of simple slopes and also test for simple slopes. It also provides regions of significance as well. So it's a really flexible tool. It's really nicely done. So at any rate, I am going to demonstrate probing a cross-level interaction effect. And the data set that I have is essentially the level one outcome variable is students' math scores. And we have a couple of level one predictors at the student level, and then we have students are nested within schools. So we have the ID variable in this data set is a student identifier. School code is the level two identifier. And so we have female and SES are going to be level one predictor variables. Female is coded 0 for male, 1 for female. SES is socioeconomic status, where higher scores indicate higher SES. It's not fully, I guess, it's not fully centered in the fact that we have, it's not exactly 0 on this particular variable, but we do have positive and negative values, and the mean of it is close to 0. We have SES mean, which is a level 2 predictor variable, and that was computed by taking the average of SES for the students within each school. So it's a composite of the level 1 information. We have this variable right here, which is referring to, I guess, sort of a proportion going to college, four-year college or whatever. And then a public variable, which is coded 0 for private school, 1 for public school. So we're going to include that. So, looking at our calculator down here for the case number 3, there are several pieces of information we want to obtain. So first of all, you'll see the basic equation, and they're using essentially the notation at level 2. You've got gamma 0, 0, which is the fixed effect for the intercept, gamma 1, 0, which is the fixed effect for the regression slope. So this would be the average slope for the level 1 predictor across groups. This is the average intercept across groups or schools. This right here is the level 2 regression slope for the predictor. And in this case, so we're going to use, in this case, our level 2 predictor is going to be the public variable, and our level 1 predictor is going to be the SES variable. So that's going to be the main predictors in the model. And so over here we have the regression slope for the interaction effect. So down here we're going to be putting in the fixed effects for the intercept, the level 1 slope, the level 2 slope, the interaction effect, and then we're going to have to have a matrix of asymptotic variances and covariances for our regression coefficients. So these boxes right here, we're going to put the asymptotic variances for the intercept, the level 1, level 2 slopes, and the slope for the interaction effect. Down here, we have the coefficient covariances, so we're going to be putting in the asymptotic covariances between the intercept and level 2 slope parameter, the asymptotic covariance between the level 1 and the interaction effect, the slope parameters for those, and so forth. So I'll kind of walk you through all that as we go through the process. So let's do this. Let's go back, and I've already set up the basic model, and we've already kind of shown that we have a significant variation across schools in terms of the relationship between SES and math. Let me also just take a quick aside and note that the data set and the example in part is kind of derived from this book right here. If you go to the book website, you can actually download the data set, so that's where this is coming from. The book doesn't really go into testing the statistical significance of slope, so that's where we're kind of pivoting off of, and so we're just going to stick with one model based on their example. So we're going to go to Analyze, go to Mixed Models, go to Linear. We have the level 2 identifier in the subjects box. Click on Continue. We have the dependent variable math. We have each of our predictor variables. And so you can see there's female, SES, or level 1 predictors, SES mean, this variable, and then the public variable is, these are all the level 2 predictors. So the public variable, just kind of keep in mind, that's associated with each school. So all the students within a given school are coded based on whether the school is public or private. Under random, you'll see that I've already laid this out. Essentially, we have SES. I just basically moved it from this box over to this box right here for the random effect. We have intercept box included. We also have the subject groupings. This is also moved over to the combinations box. And then I'm going to stick with the variance components for the covariance type for this demonstration. So then under fixed, this is the basic model that we're going to be working from. So I'm going to just kind of show you really quickly how this works, because these are all the main effects within the model, and then we have the interaction effect between public and SES that we want to ultimately test and probe. So just kind of starting from the ground floor, I'm just going to make sure this is set to main effects, and then highlight all these and move them over. And then to generate the interaction term, I'm just going to click on public, this arrow by SES, that arrow, and then click add, and there you go. So now we have that set up. Under estimation, I'm going to stick with maximum likelihood, and under statistics, I've clicked on parameter estimates, test for covariance parameters, and then this right here is going to generate the asymptotic variance covariance matrix. So, so be sure that you click on that because we're going to need that in order to feed that information into the utility. So now I'm going to click on OK, and so now that I've run it, we've got two important boxes right here when it comes to filling in this calculator. So first it says regression coefficients. So we're going to fill in the fixed effect for the intercept, level 1 predictor, level 2 predictor, and the interaction term. So you'll notice that we do have more than just we have more than just two predictors in the model, and that's okay. It's not, there's nothing wrong with it. We can just use the coefficients associated with our interaction. That's what we're mainly focused on. So I'm going to double click on this, and it just makes life a lot easier if you can just copy and paste from your SPSS output into the program. So there's the fixed effect for the intercept. The level 1 predictor, there's the slope for the level 1 predictor, so I'm going to paste that in here. For the level 2 predictor, which is the public variable, I'm going to copy, paste that in, and then for the interaction effect, down here, I'm going to copy and paste this in. Then for the coefficient variances, I'm going to go down here, and you've got the matrix of asymptotic variances and covariances associated with your regression parameters. So, just keep in mind that along the primary diagonal of the matrix, these are all going to be asymptotic variances for each of the regression parameters. And then on the off diagonal, you have asymptotic covariances. So the elements that are below the principal diagonal are going to be covariances, and then those same elements also are reproduced above. So there's nothing kind of special about what's happening above and below the principal diagonal. So now what I will do is I'm going to use this little guidepost here. So I want the asymptotic variance for the intercept, which is going to be right here. You've got if you double click here, you've got intercept right here and intercept right here. So that's the asymptotic variance associated with the intercept. So I'm going to copy that and paste it in here. Then we've got the asymptotic variance for SES, the level 1 predictor. So SES, SES. So there's the asymptotic variance for that. So I'm going to paste that in. Then for the level 2 predictor, we're going to go public, public, and there's the asymptotic variance for that variable, or for that coefficient. And then for the intercept, we've got the interaction, and so this will be the asymptotic variance for the slope for the interaction term. So I'll paste that in. Then for the covariances, you can see we've got the asymptotic covariance between, kind of going back and looking at our formula right here and how this is laid out. The first one is the covariance between the intercept and the level 2 slope parameter. So in this particular case right here, I'm just going to go back to my output, intercept, level 2 slope parameter, and so this is it right here. There's public, and there's the asymptotic covariance. So I'll copy and paste that in. Then we have the covariance between the slope for the level 1 predictor and the interaction term. So in this particular case, we're going to go to SES and then go down here for the interaction term, and so there's the asymptotic covariance for that. We'll do the asymptotic covariance between the intercept and the level 1 slope. So there's intercept, level 1 slope right here. So there's the asymptotic covariance for that. And then we've got the level 2 slope right here, and the level 2 for the level 2 predictor. And then we have the slope for the interaction term. So in this particular case, we'll go back to we got level 2 and then the interaction term. So there's the asymptotic covariance for that. So you'll see that in theory we could theoretically add degrees of freedom, but we're just going to leave this alone. And what's going to happen is that if we generate different effects and so forth, it's going to be in the form of z-scores. So at this point, if I just click right here, also it says check this box if W1 is dichotomous, and it is. So I'm going to click on this, click on calculate. By the way, you could also set alpha different levels too. So now you can see it says case 3, interaction, two-way interaction. So this is all the information I fed into the program, the asymptotic variances and covariances. You've got regions of significance that are printed out, and I'm not really going to spend much time on that, but just kind of letting you know that that is indeed there. Most of the time, or quite often, individuals want to test simple slopes. So in other words, looking at the relationship, for instance, between our level 1 predictor SES and math, looking at that predictive relationship at different conditional levels of our level 2 predictor. So our level 2 predictor, again, is a public variable. It's coded 0 for private, 1 for public. So to probe, to generate simple slopes, then what I'm going to do is I'm going to go over here, and so you can see it says W1. So that's our our level 1 predictor variable, and you've got 1, 2, and 3. And so what I'm going to do is I'm going to type in a 0 here and a 1 here because that's the coding on our level 2 predictor. If our level 2 predictor had been continuous, then I certainly would not be clicking here. And also, when it comes to conditional values, I probably would end up using, picking 3 points along the scale to plot out to plot out the simple slopes. So we are essentially plotting out slopes for the relationship between x1 and our predictor variable at level 1 and our outcome at different levels of our moderator at level 2. So I'm going to type in 0 right here and 1 right here. And so we, at this point, if you have a dummy coded variable, we can do this. We don't have to fill in this right here. But like I said, if I had a variable that that was treated as continuous, then I might do something like type in, put in the mean of the variable here, and then put in the value that is 1 standard deviation below the mean, and then 1 standard deviation above the mean. So that's kind of a conventional way in which you might use the pick a point approach. So now I'm going to do incorporate 3 points along for the X predictor. So what I've done is I've gone ahead and just generated the descriptive statistics on our SES variable. We have the mean of 0.0139, standard deviation is 0.78078. So these are 3 arbitrary points, but basically we have we're going to treat the mean as a sort of a medium level on our SES variable, and it's 0.0139. So like I said, it's not exactly 0, but it's pretty close. Then we took the mean and subtracted the standard deviation here to get this value, and the mean, and added the standard deviation to get this value right here. So now I'm just going to copy these values and paste them in for x1, x2, and x3. Like I said, these are arbitrary points, but this is kind of a conventional way that simple slopes are kind of generated. So now I'm going to click on calculate, and so now when I go down, you can see that we have all our other information. We have the regions of significance information that's available, but the main thing that I'm looking at are the simple slopes. So what we have right here, we have the intercept and the slope for the simple regression line. So essentially the regression line for the relationship between SES and math scores in the public schools and in the private schools. So we have the intercept and the slope for each of those regression lines. So you'll see right here it says W1, the value that was in that one box above was 0 for the, so there's a little 1 box right there. It was 0 for private school. For the 2 box, it was the public school. So if you go down here and you look at W1, this would be for the private schools. You can see this is the slope, the standard error, the z value, and then you get a p value, and it's rounded off, but basically it's less than the 0.05 level. So that would be indicating that we have a statistically significant slope for the pertaining to the relationship between SES and math scores. Then in the public schools that we have right here, you can see we have the slope, the standard error, z-value, and significance level. So you can see that the slopes in both cases are statistically significant. But you also notice that the slope is a little bit stronger in the private school as opposed to the public school. Now, we can also scroll down a little bit further, and if we want to plot out the simple slopes, we can click on this button right here. It says Submit Above to our web. And so when I click on this, we get our plot. So you can see the W1 with the one in parentheses, that was our private school variable, or private school level. And then for 2, it was the public school level. So you can see that the dotted line is for the public schools. The non-dotted line is just basically for the private schools. So you can see the relationship being stronger between SES and math scores in the private school as opposed to the public school. So there you go. That's essentially a plot of the simple slopes. And again, if we go back, you can see that we were able to test out the simple slopes here. And the other option, there are other options available in terms of regions of significance that are available to you. I'm not really, like I said, I really wasn't aiming to go into all that, but just just kind of sticking with the conventional approach to probing the interaction effect. Just kind of note, I think the authors of the website note this already, but if it's the case that that you're basically what's happening is that the program is generating syntax, R syntax right here, and so it's essentially submitting to an R web. But if the R web is not up and running, then evidently you can just copy this and paste it into the R program and run it and generate your plot as well. So that is available to you if this R web function is not working. So that pretty well concludes much of this discussion. Like I said, you have you have 3 different calculators reflecting 3 different cases. So if you just follow along with the general flow that I've shown you, that you can get pretty much what you need. Just keep in mind that once again that what we used right here, we had a dichotomous variable. So we clicked on this little button right here, and and then in terms of our conditional values, we had the 2 levels of our dichotomous level 2 variable. But again, if we happen to, if our level 2 predictor variable was continuous, then we would have followed the same strategy that we used down here with our level 1 predictor. So that pretty well concludes this discussion, and I hope you find this useful.